Honest, a lot of games have memory leaks, and most of the time, the source of the memory leak is unknown. Sure, you can use cleanup libraries, but does that really solve the issue? You still might run into memory leaks and never know where they're coming from. Frankly, every project tends to have some sort of issue that's very similar to this. So I built something to fix that. And it's not another cleanup library. Instead, it's something that thinks about the problem differently. It's called Steward. I want to show you why it's not just another cleanup library, instead it's something entirely different. And today I'm walking you through Steward, which is a library I made because I got tired of cleanup code drifting out of sync with what my game was actually needing. So, if you're the type of person who just wants to cut to the chase, which I fully understand, I am going to summarize this for you. So, Steward is a hierarchical lifetime ownership framework, and cleanup is not the feature, instead, ownership is the feature, and it's hierarchical, meaning a steward can own other stewards, not just connections and instances. And it just happens that cleanup just falls out of that for free. Now, stick with me because that's gonna make a lot more sense in about 2 minutes. So, let's talk about why most cleanup patterns kind of suck, even the good ones. So, as an example, I will be using maid. Comparing my library to maid will be wrong as they're different libraries. Okay, they're completely different. But I will still be using maid solely as an example, not comparison. So don't forget that. So cleanup libraries give you a bag. You throw connections in the bag. The bag dies and everything in the bag does as well. Now that's fine, okay, because that works for one object. But your game isn't one object. Think about the actual shape of what you're building. Okay? Say you've got a match. The match has teams. Each team has players. Each player has a character, some connections, maybe some UI. That's a tree. It's a tree whether you write it down as one or not. The second you're managing that with a flat list of mates, one per object, you've basically recreated the tree by hand, except now you have to remember to wire it up yourself. Now, say the player leaves. You gotta remember to clean up their maid, and their team's mate does not know or care what happened. And if the round ends, you better remember to look for every single one of those mates yourself, because nothing's actually calling them for you. That's mostly where memory leaks come from. Not from anyone mate being broken, from the wiring between them being manual and easy to forget. So, here's the flip. What if you just wrote the tree down? For real, as code, okay? That's the whole match team player relationship expressed directly in Steward or using Steward. As you can see, there's no made per object that you have to remember to wire together, okay? The Steward tree literally is the ownership structure of your game. And once the tree exists, just have a look at what you get for free. One call at the rope and it just cascades everything, okay? So every team, every player under every team, every connection and instance any of them were holding, it's all gone just with one shot. Because you already told the framework who owns who back when you built the tree. See how you didn't write any cleanup code just now? Now let's get into how you actually use this thing. Because every steward node can adopt stuff, which means you can adopt connections, threads, tweets, instances, even your own custom classes as long as they have a destroy or disconnect method. And client functions for that's anything that's, well, custom. What am I saying? There's a specific method for each kind, or you can just call the generic one and let it figure out what you handed it. Now, here's a part that actually matters for correctness though. Every one of those resources belongs to exactly one steward at a time. One. If you adopt something that's already owned somewhere else, the ownership moves, okay? It does not duplicate. Now, without that guarantee, you could end up with the same cleanup function firing twice on dismissal. You don't want that. So, let's talk about what dismiss really does. Because the order matters and it's worth understanding once instead of guessing. Here there's a numbered list on the screen and it shows you the order of the stuff that get removed when you call dismiss. So Notice children get torn down in step 5 before your own instances and cleanup functions run. That means if you write a add cleanup function, it's going to run dead last after your children already gone. So that means do not write a cleanup function that expects a child steward stuff to still be there, because it won't be. So that's a small detail, but it will save you a confusing bug later on. So everything in this whole dismiss thing is wrapped in a safe call too. So that means one bad destroy throwing an error does not stop the rest of the branch from tearing down. It just warns and keeps going. So that's on purpose, because a single broken resource should not be able to wreck an entire branch's cleanup. Now let's move over to debugging. This is honestly my favorite part, because it comes basically free once you've built the tree. Oh, that rhymed, holy shit. So here, in this code, just have a look at it, okay? We created 2 snapshots and we compared the difference between them. And in the output, we will get something like this. So since the tree mirrors your actual game state, you can snapshot it at any time, okay? During that, no life references are held. So keeping a snapshot around never keeps anything alive. That's good. That's one good thing. Moreover, you can diff 2 snapshots against each other like I just showed you. So let's move over to match dump. That will print something like this. As you can see, dump just prints the tree as it stands at the moment. Real quick, things I'd actually tell you to do and not to do with this. Meaning, let's move over to the good and bad practices. A good practice would be to name your stewards. Match, player underscore user ID, just whatever makes sense, okay? Because if you don't, your dumps will turn into a wall of steward number 42 or steward number 87, something, whatever. And you just have no idea which one is which when you're actually trying to debug something. So, name your stewards, okay? You'll be saving yourself a lot of time. Also, build the tree that matches your real game structure, okay? Do not shove everything under one giant root for the whole server. You'll lose the ability to tear down just a round or just a player, okay? And also, don't leave a bunch of unnested stewards just floating around either, because an orphaned one with no parent never gets dismissed unless you remember to do it yourself, which just defeats the entire purpose of steward. One last good practice is to let your cleanup functions capture what they need for the closure. That means you should not try to reach out some external variable that might already be gone by the time dismissal actually runs. What that means is just put the function in there. Do not try some fancy bullshit. Just let it do its thing, okay? It will work. Also, I noticed that I called this the good and bad practices, but I'm only gonna say good practices. Whatever. I'm just gonna go away. I'm just gonna devour to the next topic. Yeah. If you're interested, the GitHub link to my repository is in the description. Okay, but listen here. Steward is at the moment unstable. It's very new. It's not at its peak. So if you try it out and hit something weird, or you've got an idea for a feature, or whatever, just do a pull request or just tell me in the comments, because I actually read those. Yeah. So if you like Steward, just give me a like, bro. Just give me something, bro. And whatever. Ow, my foot. And I'll catch you in the next one. Bye bye.